First, write down fundamental principle of counting. Fundamental principle of counting. Fundamental principle of accounting are of two types. Fundamental principle of multiplication The second one is fundamental principle of addition. First one is fundamental principle of multiplication. Second one is fundamental principle of addition. First come to fundamental principle of multiplication. Who are present today: Anveshan Nayak, Varsha Priyadarshini, Bharti, Vijay, Government Women's High School, Sambalpur, Kendrapada Evening High School, Pankaj, Pooja, roll number 90, Sweetie Diggle. Okay, 14 participants are there. So let's write what the fundamental principle of multiplication says. The principle says that if an event occurs in m different ways, and for each way of occurrence, of the first event, another event occurs in n different ways, then the number of ways both the events can occur in m into n different ways. Okay. Fundamental principle of multiplication says if an event occurs in m different ways, and for each way of occurrence of the first event, another event occurs in n different ways, then the number of ways both the events can occur is in m into n different ways. Let me explain it. Suppose there is an event E1 which occurs in m different ways. This is suppose first way of occurrence of the event E1. This is second way of occurrence of the event E1. This is third way of occurrence of the event E1. And this is nth way of occurrence of the event E1. So event E1 can occur in m different ways, and it is given that for each way of occurrence of the first event E1, another event E2 is there which can occur in n different ways. That means for first way of occurrence of the event E1, another event E2 is there which can occur in n different ways. For second way of occurrence of the event E1, event E2 can occur in n different ways. For third way of occurrence of the event E1, event E2 can occur in n different ways. And similarly, for nth way of occurrence of the event E1, event E2 can occur in n different ways. So total number of ways, according to the first way of occurrence of the event E1, both E1 and E2 can occur in n ways. For second way of occurrence of the event E1, both E1 and E2 can occur in n ways. For third way of occurrence of the event E1, both E1 and E2 can occur n ways. And similarly, for nth way of occurrence, both m and n can occur in n ways. Thus, the total number of ways both the events can occur equals n plus n plus n plus up to n. How many times? M times. This is equal to m times n. I hope it is clear to you. Please write in the chat box. Is it clear? Pankaj? Okay. In another way also, we can describe fundamental principle of multiplication in more lucid way. That way is, yes, Vijay. Quickly note it down. I'll go to the next page. Vijay, is it clearly visible? Are you able to read what I am writing in the paper? Okay. Done. Have you finished writing? Okay. The fundamental principle of multiplication can be also explained in another way. Write down. Or if J1 and J2 are two dependent if J1 and J2 are two dependent subjobs of job J such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M into N different ways. If J1 and J2 are two dependent subjobs of job J such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M into N different ways. Let me explain it. Suppose there is a main work J. A main work ଦୁଇଟା ପ୍ଲେ sub work ଅଛି ବା sub job ଅଛି ଗୋଟେ ହେଲା J1 and another one is J2. These are two dependent sub jobs. Dependent sub jobs means ଯଦି ଏଟା ଦୁଇଟା ପାର୍ଟ ଅଛି ସବ୍ ପାର୍ଟ ଅଛି ଜବ୍ର ଯଦି J1 complete ହେଉଛି J2 complete ହେଉଛି and then we can say that the main job is complete. If any one of them remains incomplete, then the main job is incomplete. This is the meaning of dependent subjob. Dependent subjob କହିଲେ both complete ହେଲେ main job complete ହେଉଥିବ ତାପରେ କୌଣସି ଗୋଟେ ଯଦି incomplete ରହିଲା main job incomplete ହେବ. Clear? And it is given that the job J1 can be completed in M different ways. This is first way, second way, third way, and this is mth way. And job J2 can be completed in n different ways. First way, second way, third way, and nth way, right? So the first way of completion of job J1 can be associated with first way of completion of J2, hence job J can be completed in one way. Similarly, the first way of completion of job J1 can be associated with the second way of completion of job J2, and it can complete the main job in another way. So accordingly, the first way of completion of job J1 can be associated with n ways of completion of job J2, which can complete the job J in n ways. Similarly, the second way of J1 in n ways, third way in n ways, and mth way in n ways. How many times? M times, which is equal to mn. Right? ତାହେଲେ ପିଲେ ଯୋଉ ପରମୁଟେସନ କମ୍ବିନେସନ ଯୋଉ କ୍ୱେଶ୍ଚିନ୍ ଆମେ ଦେଖିବା ଫାଷ୍ଟ ଅଫ୍ ଅଲ୍ ତୁମକୁ ଡିସାଇଡ୍ କରିପାରିବ ତୁମକୁ ମେନ୍ ୱାର୍କ କ'ଣ ଦିଆହେଇଛି ତୁମକୁ କ'ଣ କରିବାକୁ କହିଛି ପରମୁଟେସନ କମ୍ବିନେସନ ଦ୍ୟାଟ୍ ଇଜ ଦ ମେନ୍ ଜବ୍ ତାପରେ ଦେଖିବା ହ୍ୱାଟ୍ ଆର୍ ଦ ପସିବୁଲ ସବଜବ୍ସ ଅଫ୍ ଦ ମେନ୍ ଜବ୍ ସୋ ପସିବୁଲ ସବଜବ୍ ଖାଲି J1 J2 ମନେକର ଗୋଟେ J1 ଗୋଟେ ସବଜବ୍ ଅଛି J2 is another subjob and J3 is another subjob of the main job J. Clear? Then you have to decide whether these three subjobs are dependent subjobs or independent. Dependent independent can decide karibo. যদি তিনটা যাক কমপ্লিট হলে মেন জব কমপ্লিট হউতব দেন ইউ ক্যান সে দ্যাট দ subjobs are dependent. যদি কৌনসি গোটে পার্ট কমপ্লিট হলে মেন জব কমপ্লিট হই যাউতব দেন দ subjobs are independent subjobs. যদি dependent subjob ଅଛି first of all you have to divide in how many different ways each subjobs can be completed. Suppose job J1 is completed in M ways, job J2 is completed in N ways, and job J3 is completed in P ways. If these three subjobs are dependent subjobs, then the main job J can be completed in M into N into P ways. Okay. So you will be more clear after two or more questions come. Okay, rudimentary questions. Question number one, very, very easy question. Write down, there are 10 boys and 8 girls in a class. The class teacher has to select a boy and girl to represent the class in how many different ways the selection can be made. There are 10 boys and 8 girls in a class. The class teacher has to select a boy and a girl to represent the class in how many different ways the selection can be made. So, what is the main job here? Class रे 10 boys अछंती and 8 girls अछंती. Class teacher को job assignment कराइछि क्लास रिप्रेजेंटेटिव आछिया पे जो क्लास को जो रिप्रेजेंट करियो गोटे पुआ और गोटे झियो रिप्रेजेंट करिवे. क्लियर? तो व्हाट इज द मेन जॉब हियर? द मेन जॉब इज टू सिलेक्ट ए बॉय फ्रॉम 10 बॉयज एंड ए गर्ल फ्रॉम 8 गर्ल्स. जदि आम खाली बॉय सिलेक्ट करके रिप्रेजेंट करने को छाड़ा ताले काम इनकम्प्लीट रहिबो. जदि खाली गोटे गर्ल सिलेक्ट करके रिप्रेजेंटेटिव बाछिबा काम इनकम्प्लीट रहिबो. जदि गोटे बॉय सिलेक्ट करबा एवं गोटे गर्ल सिलेक्ट करबा तांको रिप्रेजेंट पे छाड़िबा ताहले यदि हम काम कंप्लीट हेबो. ताहले सिलेक्शन ऑफ अ बॉय इज ए सब जॉब, सिलेक्शन ऑफ अ गर्ल इज अनदर सब जॉब, एंड दीज टू सब जॉब्स आर डिपेंडेंट सब जॉब्स. कहीं माने कौन सी गोटे सिलेक्ट हेले काम कंप्लीट होनी, बोथ सिलेक्ट हेले काम कंप्लीट होची, ताले एटा डिपेंडेंट केस. सो फर्स्ट selection, let J1 be the subjob of selecting a boy and J2 be the subjob of selecting a girl, and these two subjobs are dependent subjobs. So first of all we have to find in how many different ways the subjob J1 can be completed. That means in how many different ways we can select a boy from out of 10 boys. A boy can be selected from 10 boys in 10 different ways. And 10टा boys अछंती, let them be B1 B2 B3 up to B10. ताले कौन क्लास टीचर B1 को सिलेक्ट करि पारंती, क्लास टीचर B2 सिलेक्ट करि पारंती, क्लास टीचर B3 सिलेक्ट करि पारंती, क्लास टीचर B10 मध्ये सिलेक्ट करि पारंती. ताले ए बॉय कैन बी सिलेक्टेड इन हाउ मेनी डिफरेंट वेज? 10 ways. So the job J1 is completed in 10 ways. Now we have to find in how many different ways the job J2 can be completed. That means in how many different ways the class teacher can select a girl out of 8 girls. A girl out of 8 girls can be selected in 8 ways. So job J2 is completed in 8 ways. Job J1 is completed in 10 ways. Since these are two dependent subjobs, so the total number of ways will be 10 into 80, that is 10 into 8, that is 80. And suppose boy 1 is selected and suppose 8 girls, girl 1, girl 2, girl 3 up to girl 8. ताले boy 1 girl 1 नेकरी आमे गोटे रिप्रेजेंटेशन बाहर कर परिया. boy 1 girl 2, boy 1 girl 3, similarly boy 1 girl 8. ताले boy 1 को नेकी केतरा वेज रही परिबो? 8 वेज रे. Similarly taking boy 2 in the selection, the procedure can be completed in 8 ways. Similarly taking boy 3 in the selection, the procedure can be completed in 8 ways. So total number of ways is equal to 8 plus 8 plus 8 up to 8 10 times, that is 10 into 8, that is 80. I hope it is clear to you. Write in the chat box, is it clear? Did you understand, guys, what I explained? It was very rudimentary question on permutation, fundamental principle of accounting. Write in the chat box, is it clear? Vijay? Yes. Okay. Good. Let's move forward to the next question. Just a minute, guys. I have to set the paper. Clearly note it down. Then come to question number 2. How many 3-digit numbers with distinct digits? How many 3-digit numbers with distinct digits can be formed by using the digits 1, 2, 3, 4? Okay. How many 3-digit numbers with distinct digits can be formed by using the digits 1, 2, 3, 4? What is the meaning of distinct digits? Distinct digits means repetition of digits is not allowed. That means in the same number, no digit can be repeated or no digit can be written more than once. That is numbers like 112 or 222. These type of numbers are not included in this. Okay. So all the 3 digits should be different. For example, 123, 234, like this. Clear? So what is the main work? The main work is to form a 3-digit number. A 3-digit number contains 3 places, such as units place or ones place, tens place, and hundreds place. Ekaka ghara, dasaka ghara, and sataka ghara. Right? So the main job here is to fill up these 3 places using the digits 1, 2, 3, 4, keeping in mind no digit can be written more than once. Clear? So to fill up the units place, let it be subjob J1. To fill up the tens place, let it be subjob J2. And to fill up the hundreds place, let it be subjob J3. যদি পিলে আমি কেবল यूनिट्स प्लेस फिलअप कले tens place, hundreds place fill up colony, your work will be incomplete. The number cannot be a 3-digit number. Suppose units place, tens place are filled up, but hundreds place is not filled up, then the number will be a 2-digit number. So here the subjobs J1 and J2 and J3 are dependent subjobs, because if all the 3 places are filled up, then only a 3-digit number will be formed, right? So the subjobs J1, J2, J3 are 3 dependent subjobs. Now we have to find in how many different ways each subjob can be completed. First of all, we have to fill up the units place. To fill up the units place, what are the digits available? The available digits are 1, 2, 3, 4. We can put 1 in the units place. We can put 2 in the units place. We can put 3 or we can put 4. So how many choices are available? 4 choices are available for the units place. So the units place can be filled up in 4 different ways. I hope it is clear to you. Once the units place is filled up, that means the digit which is taken in the units place can't be taken in the tens place, because repetition of digits is not allowed, right? So once the units place is filled up, how many digits are left with you to be filled up in tens place? 3 digits are left. So the tens place can be filled up in 3 different ways. So units place is filled up, tens place is filled up. After filling up the units place and the tens place, how many digits are left with you? 2 digits are left. So that the hundreds place can be filled up in two different ways. So the total by fundamental principle of multiplication, all the three places can be filled up in how many different ways? 2 into 3 into 4, which is equal to 12 ways. So by using the digits 1, 2, 3, 4, if repetition of digits is not allowed, how many three-digit number are possible? Only 12 three-digit numbers are possible. Is it clear? Write in the chat box. Pooja, Vijay, is it clear? Yes, Varsha. Good. So, oh, it is 24. Sorry, it's 24. Then another question. I hope you can handle this question. Try to solve this question and send me the answer. Next question is, how many three-digit numbers with distinct digits how many three-digit numbers with distinct digits? If distinct digits is written, then you will think that repetition is not allowed. How many three-digit numbers with distinct digits can be formed by using the digits 0, 1, 2, 3, 4? So guys, try to answer this question, solve it, and send me the answer to chat box. 48. Yes, Pooja, you are correct. Forty, no, Bharti. 40 is not the correct answer. Okay, let me solve it. We have to form a three-digit number. We have to find how many three-digit numbers are possible. Okay, what are the digits to be used? 0, 1, 2, 3, and 4. Since 0 is there, and 0 can't be taken in the extreme left position. If 0 is taken in the extreme left position, the number will be a two-digit number. So we should start filling up the position from the left-hand side. So the extreme left position, which is your hundreds position or hundreds place, can be filled up in four different ways. Once this place is filled up, how many digits are left with you? Four digits, because in the second position and third position, that is in the tens position and ones position, 0 can be taken. So second position can be filled up in four ways, and the ones place can be filled up in three ways. Thus the total number of ways is equal to 4 into 4 into 3, which is equal to 48. Is it clear to you? Okay. Next question. Answer is 180. How many four-digit even numbers can be formed using the digits 0, 1, 2, 3, 4, 5 if repetition of digits is not allowed? Okay, this is the question. Should we go for the solution? Roll number 90, Kendrapada Evening Higher Secondary School. Answer is 180. Okay, let me answer the question. Four-digit even number, four places, units place, tens place, hundreds place, and thousands place. Okay, units place, tens place, hundreds place, and thousands place. So the number will be an even number if the unit place digit is an even digit. That means if you can take 0 or 2 or 4, meeting group 0 ଆସିପାରିବ କି ବିଜୟ? Actually କଣ ପଚାରୁଛ ମୁଁ ଜାଣିପାରୁନି. So units place can be filled up by 0, or units place can be filled up by 2, or units place can be filled up by 4. So the units place can be filled up in 3 different ways. Okay, clear? Answer is 144. Vijay, I think you are correct. Let me answer it. Then we'll match. So units place can be filled up in 3 different ways. Either we can take 0 at the units place, or 2 at the units place, or 4 at the units place. Once the units place is filled up, so one digit is occupied by units place. So how many digits are left? Total 6 digits are there. So 5 digits are available for the 10th place. So this place can be filled up in 5 ways. This place can be filled up in 4 ways, and this place can be filled up in 3 ways. So total number is 180. But this is not the correct answer. Why? In this type of arrangement, there is possibility that 0 may be at the extreme left position. So then we have to calculate how many even numbers are possible by taking 0 at the extreme left position. Those number of numbers should be subtracted from 180. Okay, I think Vijay is correct. So now put 0 in the extreme left position. Okay, and we have to form even numbers taking 0 at the extreme left position. So for even numbers, the units place can be filled up either by 2 or by 4. This can be done in 2 ways. Okay, so 2 digits gone. How many digits are left? 4 digits are left. So this place can be filled up in 4 ways. This place can be filled up in 3 ways. A total number of ways is equal to 24. So taking 0 at the extreme left position, 24 number of even numbers are possible. So these numbers are not 4-digit numbers. These numbers are 3-digit numbers. So total number of such numbers is equal to 180 minus 24. Okay. This is equal to 156. What was the answer given by Vijay? Let me check it. 144, no Vijay? How come it is 144? Yes, it is 24. Answer is 156, correct answer. Did you understand, Vijay? Sir, ବୁଝି ହିଲାନି again କୁହନ୍ତୁ. Yes, sir, କହିଦେବା again. ପୁଣି କହୁଛି again କହୁଛି. ଆମକୁ 4-digit number formation କରିବାର ଅଛି, and that should be an even number. ପୂଜା କ୍ଲିୟରଲି ଶୁଣୁଥାଅ. ତାହେଲେ ଆମକୁ ୟୁନିଟ୍ସ ପ୍ଲେସରେ ଆଇଦର 0 ନେବା, ୟା ତ 2 ନେବା, ୟା ତ 4 ନେବା. তাহলে ୟୁନିଟ୍ସ ପ୍ଲେସରେ ଆଇଦର 0 ନେବା, or 2 ନେବା, or 4 ନେବା. ୟୁନିଟ୍ସ ପ୍ଲେସ କେତେ ୱେଜରେ ଫିଲ୍ଅପ୍ ହବ? 3 ୱେଜରେ ଫିଲ୍ଅପ୍ ହବ. ତାପରେ 10th ପ୍ଲେସ 5 ୱେଜ, 100th ପ୍ଲେସ 4 ୱେଜ, 1000 प्लस 3 टोटाल 180 आंसर हवा कथा ना आम जो ये आरेंजमेंट कले मन इच्छा आरेंजमेंट कले या पॉसिबिलिटी अच्छी जीरो एक्सट्रीम लेफ्ट पोजिशन रहार जीरो जदि एक्सट्रीम लेफ्ट पोजिशन रही जो इभेन नंबर गुड़िक हम से 4 डिजिट न 3 डिजिट हे आमको काल्कुलेट करा पड़ो जीरो एक्सट्रीम लेफ्ट पोजिशन थी केतोटी इभेन नंबर होची जीरो को आम एक्सट्रीम लेफ्ट पोजिशन रे प्लेस करदे तापर देखा इभेन नंबर फॉर्मेशन करवा यूनिट प्लेस आइदर 2 और 4 दिस कैन बी डन इन 2 डिफरेंट वेज वंस दीज 2 प्लेसेस आर फिल्ड अप 2 डिजिट्स पढ़ेले आउ रहिले केतटा 4टा डिजिट दिस प्लेस कैन बी फिल्ड अप इन 4 वेज एंड दिस प्लेस कैन बी फिल्ड अप इन 3 वेज so taking zero at the extreme left position 24 number of even numbers are possible and these numbers are not 4 digit numbers these are 3 digit numbers यही नंबर गुड़ाक 180 भितर इनक्लूड अच्छा से नंबर गुड़ाक माइनस करदे 180 माइनस 24 इज इक्वल टू 156 आई होप इट इज क्लियर पूजा इज इट क्लियर नेक्स्ट मूव फॉरवर्ड टू द नेक्स्ट क्वेश्चन नेक्स्ट क्वेश्चन हाउ मेनी 5 digit numbers how many 5 digit numbers divisible by 3 can be formed. Just a minute, guys. I have to attend a call. Hello. How many 5 digit numbers with distinct digits? With distinct digits means repetition is not allowed. How many 5 digit numbers with distinct digits and divisible by 3 can be formed by using the digits 0, 1, 2, 3, 4, 5. How many 3 digit numbers with distinct digits and divisible by 3 can be formed by using the digits 0, 1, 2, 3, 4, 5? How many five-digit numbers with distinct digits and divisible by 3 can be found by using the digits 0, 1, 2, 3, 4, 5? So guys, let me know how to check whether a number is divisible by 3 or not. What is the rule? A number is divisible by 3 if its sum of digits is divisible by 3. Since we have to form a 5-digit number divisible by 3 using the digits 0, 1, 2, 3, 4, 5, out of the 6 given digits, we have to select those 5 digits whose sum is divisible by 5, divisible by 3. So if you take 1, 2, 3, 4, 5, their sum will be 15. So any number formed by using 1, 2, 3, 5 taken all together will be divisible by 3. Okay. So first of all, we have to calculate how many 5-digit numbers are possible by taking 1, 2, 3, 4, 5. Okay. So sum of the digits will be 15. If since sum of the digits is 15, so any number, any 5-digit number found by using these 5 digits will be divisible by 3. So 5-digit number contains 5 places. This is first place or units place, tens place, hundreds place, thousands place, and 10,000 place. So since 0 is not there, so directly we can fill up all the places 5, 4, 3, 2, 1, which is equal to 1 into 2 into 3 into 4 into 5, which is equal to 120. Okay, then is there any other combination of 5 digits whose digit sum is divisible by 3? Yes, that another combination is, so one digit is there which is divisible by 3, the digit 3 itself. So if you drop the digit 3 and include 0, again the digit sum will be divisible by 3. So we can take 0, 1, 2, 4, 5. What is the digit sum? 5 plus 4, 9, 2, 11 plus 1, 12, which is divisible by 3. So taking 0, 1, 2, 4, 5, how many 5-digit numbers are possible? Since 0 is there, it is better to start filling up from the left hand side. So this place can be filled up 4 ways because 0 can't be taken. Then this place can be 4 ways. 3, 2, 1. 4, 4 is 16, 3 is 48, 2 is 96. So is there any other combination? No, no other combination is available. So total number of such numbers is equal to 190 plus, 120 plus 96 is equal to 216 is the answer. Okay, did you understand guys? ବୁଝିହେଲା କି ନାହିଁ ଚାଟ୍ ବକ୍ସରେ ଜଣାଅ। Hello, yes, Pooja. Good, good, good. Okay. Next question. Okay, Vijay. How many 4-digit numbers with distinct digits and divisible by 4 can be formed how many 4-digit numbers with distinct digits and divisible by 4 can be formed By using the digits 0, 1, 2, 3, 4, 5. Anybody? What is the answer? The total number of 4 digits that can be formed is 60. Sai Abhishek Acharya, MSP Spark. MSP Spark or MPS Spark? Sai Abhishek, what is the meaning of MSP? Roll number 90, answer is 56. Sai Abhishek, answer is 60. Okay. Okay. Then BJ, answer is 75. I think none of the answer is correct. Okay. So we can say, what is the rule that a number is divisible by 4? Programming Spark. Prince. What is written? Let me. Math Science Programming Spark. Math Science Programming Spark, MSP. Which higher secondary school? Okay. So 4-digit number, a number will be divisible by 4 if the number SBM, oh, Swami Vivekananda Jagatsinghpur. Okay, good. So a number is divisible by 4 if the number formed by its last 2 digits is divisible by 4. Okay. So first of all, we have to check. So taking 1, 2 in the last 2 positions, we can have some 4-digit numbers. Similarly, taking 2, 0, 2, 4, then 3, 2, then 4, 0, then 5, 2. These are the possibilities, isn't it? Taking 1, 2 in the last 2 positions, taking 2, 0 in the last 2 positions, taking 2, 4 in the last position, 32, 40, 52. Is there any possibility? I think no. Okay. So 1, 2, 3, 4, 5, 6. Out of the 6 possibilities, in 2 possibilities, 0 is taken. That is 20 and 40. 20 and 40. How many digits are there? 1, 2, 3, 4, 5, 6. 2 0 are taken in the extreme last position, right position. So other 2 positions can be filled up in 4 into 3. That is 12 ways. So this can be also done in 12 ways. So 12 plus 12 is 24. Okay. Then 12 or 24, 32 and 52. In all these cases, so 2 digits 1, 2 already has taken in the first 2 positions. Then other 2 positions, since 0 is there, this place can be filled up in 3 ways. And this case can be filled up in 3 ways. So 0 can't be taken in the extreme left position. This can be done in 3 ways. 3 3s are 9. And how many cases? 4 cases. That is 36. So 36 plus up 24 is equal to 60. I think any other 1, 2, 2, 0, 2, 4. 3, 2 is yes, 3, 2 is there. Then 4, 0. Yes. 5, 0 is not 5, 2. BJ answer 75. No. So answer is 60. The total, yes. Sai Abhishek answer is correct. It is 60. Okay, let's move forward to the next question. Then we should go for fundamental principle of addition. I think this part is clear. Fundamental principle of multiplication. Then we should go for fundamental principle of addition. Last step, Pooja, this one. Are you asking about this one? ମାନେ 12, 24, 32, 52 ନେଇକି ଆମେ କରିପାରିବା ଲାଷ୍ଟ ରଖିକି। ଯଦି 12 ଲାଷ୍ଟ ରହିଗଲେ ଆଉ ରହିଲା ଚାରିଟା ଡିଜିଟ ଭିତରେ ଜିରୋ ଅଛି, ଜିରୋ ଏକ୍ସଟ୍ରିମ୍ ଲେଫ୍ଟ ପୋଜିସନରେ ନେଇପାରିବାନି, ତାହେଲେ ସେଟା 3 ୱେଜରେ ଫିଲ୍ଅପ୍ ହବ। ଜିରୋ ଏଠି ଫିଲ୍ଅପ୍ କରିସାରିଲା ପରେ ଅଲରେଡି 3ଟା ପ୍ଲେସ୍ ଫିଲ୍ଅପ୍ ହେଇଗଲା। ସୋ this position, that is the third position, can be filled up in 3 ways. 3 into 3, 9 ways. So taking 1, 2 at the extreme right position, 9 numbers are possible. Similar is the case for 24, 32 and 52. So 9 4s are 36. So previously kete is 24, 36 plus 24 is 60. Okay. Then write down fundamental principle of addition. Then come to fundamental principle of addition. Okay. Fundamental principle of addition. The principle says that if J1 and J2 are two independent if J1 and J2 are two independent subjobs of job J, such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M plus N different ways. M plus N different ways. If J1 and J2 are two independent subjobs of job J, such that J1 and J2 can be completed in M and N different ways, then the job J can be completed in M plus N different ways, right? ତାହେଲେ ବୁଝିବା କଣ କହୁଛି ଯେ ଗୋଟେ ଜବ୍ ଦେଇଛି J1 and J2 are two independent sub jobs. ଆମେ ୟା ପ୍ରିଭିୟସ୍ କେସରେ ପଢୁଥିଲେ ଡିପେଣ୍ଡେଣ୍ଟ ସବ୍ ଜବ୍, ये କେସରେ ପଢୁଛେ ଇଣ୍ଡିପେଣ୍ଡେଣ୍ଟ ସବ୍ ଜବ୍। डिपेंडेंट सब जब कहले कौन बुझुतले ना जदि बोथ कंप्लीट होतला मेन जॉब कंप्लीट होतला या भितर कौन से जने गोटे जदि इनकम्प्लीट होतला मेन जॉब इनकम्प्लीट फॉर इंडिपेंडेंट सब जॉब माने दीटा पार्ट ओनली जदि J1 कंप्लीट हो जाउची मेन जॉब विल बी कंप्लीट जदि J2 कंप्लीट होउची मेन जॉब भी कंप्लीट ताले J1 टा जदि M वेज कंप्लीट होउची J2 टा N वेज कंप्लीट होउची ताले सिंपली दीटा पार्ट ओनली so according to J1 J can be completed in MOH and according to J2 J can be completed in NOH. So total number of OH is M plus N. खाली इंडिपेंडेंट डिपेंडेंट केमती चेक करिवो जदि बोथ कंप्लीट हेले मेन जॉब कंप्लीट होतो कौन सी इनकम्प्लीट रहले मेन जॉब इनकम्प्लीट रहउतबो दैट इज डिपेंडेंट केस जदि कौन सी गोटे कंप्लीट हेले मेन जॉब कंप्लीट होतबो दैट इज इंडिपेंडेंट केस ओके कम टू क्वेश्चन there are 10 boys and 8 girls in a class. The class teacher has to select either a boy or a girl. There are 10 boys and 8 girls in a class. The class teacher has to select either a boy or a girl to represent the class in how many different ways? The selection can be made. There are 10 boys and 8 girls in a class. The class teacher has to select either a boy or a girl to represent the class in how many different ways the selection can be made. Okay, this is the question. So, what is the main job? Main job to select a class representative, and that class representative may be a boy or a girl. So, how many boys are there? 10 boys. How many girls are there? 8 girls. A boy out of 10 boys can be selected in 10 ways. A girl out of 8 girls can be selected in 8 ways. तो क्लास रिप्रेजेंटेटिव ପାଇଁ बॉय पठेले चलिबो गर्ल्स पठेले भी चलिबो जदि बॉय पठेबा क्लास रिप्रेजेंटेटिव दैट कैन बी डन इन 10 ways जदि गर्ल पठेबा दैट कैन बी डन इन 8 ways so total number of ways is 10 plus 8 that is 18 I hope it is clear साई अभिषेक विजय पूजा okay next question there are 20 delegates Yes, Abhishek. Yes, Pooja. There are 20 delegates in a conference. There are 20 delegates in a conference. If every individual, if every individual handshakes with the other, then find the total number of handshakes. There are 20 delegates in a conference. If every individual handshakes with the other, then find the total number of handshakes. This is the question. Try to answer. विजय, अभिषेक, पूजा, पंकज. What is the answer? Oh, 190. Yes, 190 is the correct answer. So there are 20 delegates or 20 persons. Let me explain the answer. Person 1, person 2, person 3 up to person 20. Person 1 केतरा हैंडशेक करिवो? 19 हैंडशेक्स. Person 2 माने person 1 ऑलरेडी person 2 सहित हैंडशेक कर देइथबो. तेनु person 2 केतरा नुआ हैंडशेक करिवो? 18, 17, person 19 करिवो गोटे. या सहित समस्त ऑलरेडी हैंडशेक कर देइथबे. So total number of handshakes is equal to 1 plus 2 plus 3 plus up to 18 plus 19. This is equal to 19 into 20 divided by 2. This is equal to 190. Okay. I hope it is clear. Then come to next question. There are 25 points in a plane of which no 3 points are collinear. There are 25 points in a plane of which no 3 points are collinear. How many different straight lines can be formed There are 25 points in a plane of which no 3 points are collinear. How many different straight lines can be formed by using these points? Using or joining these points. This is the question. So guys, your first session is over. Your first session is 7:30 to 9 a.m. Then there is 15 minutes gap. Then 9:15 to 10:45. If you want to take a gap of 15 minutes, so do you want 15 minutes leisure? I think it will be better. Attested पढ़े दबा अभिषेक भावचे attested से 10:45 10:30 पर्यंत पढ़े दबा ତମେ ବୋର ହଉଛ କି? ଯଦି ବୋର ହଉଛ ତାହେଲେ ମୁଁ ତମକୁ ଗ୍ୟାପ୍ ଦେବି। ଅଦରୱାଇଜ କିଛି ଦରକାର ନାହିଁ, ଏକାବେଳେ ପଢିଦେବା 10:30 ରାପ୍ ଅପ୍ କରିଦେବା। କାରଣ ଏଇନା ଗ୍ୟାପ୍ ଦେଲେ ବହୁତ ପିଲା ଡିସକନେକ୍ଟେଡ ହେଇଯିବେ, ତାପରେ ପୁଣି ଆସିବେନି, କିଛି ଲାଭ ହବନି। ଓକେ, ଠିକ ଅଛି, ଆମେ କଣ୍ଟିନ୍ୟୁ କରିନେବା। ତମେ ତ ଘରେ ପଢୁଛ, ମୁଁ ଘରୁ ବି ପଢଉଛି, କାହିଁକି ନା ଆଜି ଆମର ଯିଏ ଅଛନ୍ତି ପ୍ରୋଗ୍ରାମ କୋଅର୍ଡିନେଟର ତାଙ୍କର ଦେହ ଖରାପ ଅଛି, ତେଣୁ ମୁଁ ଘରୁ ନଉଛି କ୍ଲାସ୍ ମୋବାଇଲରେ। ଅଦରୱାଇଜ ମୁଁ ତ ଷ୍ଟୁଡିଓରୁ ନେବା କଥା। Answer is 300. Okay, let me check. I think you are correct. 24 into 25 divided by 2, 25, 12 ja 300. Yes, you are correct. So there are 25 points. No 3 points are collinear. So like it's point 1, point 2, point 3, point 4, and point 25, right? So point 1 can be joined with other points in 24 ways. So 24 straight lines are possible. तो अच्छा पॉइंट टू केतरा दबो ना पॉइंट वन सहित पॉइंट टू ऑलरेडी जॉइन हो जाइए पॉइंट टू कैन गिव यू 23 न्यू स्ट्रेट लाइन्स पॉइंट थ्री 22 पॉइंट फोर 21 पॉइंट 24 1 and point 25 0. So total number of straight lines equals 1 plus 2 plus 3 plus up to 24, which is equal to 24 into 25 divided by 2, which is equal to 300. पहले मैं तुमको 15 मिनट्स ब्रेक देलिनी आम 15 मिनट्स बिफोर क्लास वाइंड अप कर दवा है ना देन कम टू नेक्स्ट क्वेश्चन फाइंड द नंबर ऑफ diagonals of a decagon. Find the number of diagonals of a decagon. Find the number of diagonals of a decagon. Abhishek, answer is 35. Yes, Abhishek, you are correct. Come to the solution. I am taking a hexagon for the sake of understanding. Then we'll convert it into a decagon. Okay. You see, a hexagon has six sides and six vertices. This is vertex 1, vertex 2, vertex 3, vertex 4, vertex 5, and vertex 6. Okay. So join of any two vertices is either a side or a diagonal. If you join vertex V1 with V2, that would give you a side. If you join V1 with V3, if you join V1 with V3, that will be a diagonal. V1 with V4, that will give you a diagonal. Okay. So join of any two vertices, so note it down. Join of any two vertices is either a side or a diagonal. Join of any two vertices is either a side or a diagonal. So the number of ways vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Okay. The number of ways vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Clear? Quickly note it down. I'll go to the next page. A decagon has 10 vertices, vertex 1, vertex 2, vertex 3, up to vertex 9 and vertex 10. Vertex 1 can be joined with other vertices in 9 ways, vertex 2 in 8 ways, vertex 3 in 7 ways, vertex 9 one way. Okay, so the total number of ways the vertices can be joined with each other is equal to 1 plus 2 plus 3 up to 9. This is equal to 9 into 10 divided by 2, which is equal to 45. So 45 is equal to, so number of ways vertices can be joined with each other is equal to total number of sides plus total number of diagonals. Total number of sides is equal to 10 plus total number of diagonals. Total number of diagonals is equal to is equal to 45 minus 10 is equal to 35. Clear? So write down a note point. The number of diagonals of a polygon of n sides equals n square minus 3n divided by 2. Total number of diagonals of a polygon of n sides equals n square minus 3n divided by 2. Okay. I hope fundamental principle of addition is also clear. So next is to move towards permutation. Before that, we should know what is factorial. Redundant factorial. The continued product of first n natural numbers. The continued product of first n natural numbers is called n factorial written as n factorial like this or n factorial like this. एमती लिखिपारिबा या तो फिर एमती लिखिपारिबा. Clear? So n factorial means 1 into 2 into 3 up to n minus 1 into n. n factorial is equal to 1, 2, 3 up to n minus 1 into n. So 2 factorial is equal to 1 into 2, which is equal to 2. 3 factorial equals 1 into 2 into 3, which is equal to 6. 4 factorial is equal to 1 into 2 into 3 into 4, which is equal to 24. 5 factorial is equal to 1 into 2 into 3 into 4 into 5 is equal to 120. And 6 factorial is equal to 1, 2, 3, 4, 5, 6. This is equal to 720. So you have to remember all these things for faster calculation. Okay. So note point, factorial of negative numbers, factorial of negative numbers and fractions doesn't exist. Okay. And there is an exception, that is 0 factorial is equal to 1. 0 factorial is equal to 1. This is an exception. Mhm. Quickly note it down. हमें यहाँ पर प्रूव करिए how 0 factorial is equal to 1. Oh, number of participants only 5. ସବୁ ପଳେଇଲେଣି? Okay. How to prove 0 factorial is equal to 1? You see n factorial is equal to 1 into 2 into 3 up to n minus 1 into n. Right? So continued product from 1 to n minus 1 will be n minus 1 factorial into n. From this step, it is clear that n factorial upon n minus 1 factorial is equal to n. That is 5 factorial upon 4 factorial will be 5. 6 factorial upon 5 factorial is equal to 6. 100 factorial upon 99 factorial is equal to 100. So n factorial upon n minus 1 factorial is equal to n. Okay, let me read your message, Abhishek. Sir, if natural numbers are involved in factorials, then how 0 factorial is coming? So या पर गोटे बहुत भल वीडियो अच्छी मु तुमको सेंड करि परिबी, बट मु खाली प्रूव करछि 0 factorial is equal to 1. This is an exceptional case. Okay. Then this is equal to n minus 1 factorial can be written as n minus 2 factorial into n minus 1 into n. This implies n factorial upon n minus 2 factorial is equal to n minus 1 into n. So if somebody asks you 80 factorial upon 78 factorial is how much? 80 factorial upon 78 factorial is equal to 79 into 80. If the question is 7 factorial upon 5 factorial is equal to 6 into 7. Okay. Similarly, the n minus 2 factorial can be written as n minus 3 factorial into n minus 2 into n minus 1 into n. This implies n factorial upon n minus 3 factorial is equal to n minus 2 into n minus 1 into n. Okay, again. So likewise, we can split or write n factorial is equal to n minus r factorial into n minus r plus 1 into n minus r plus 2 up to n minus 1 into n. This implies n factorial upon n minus r factorial equals n minus r plus 1 into n minus r plus 2 up to n minus 1 into n. This is very, very important reduction. You have to remember this. N factorial upon n minus r factorial is equal to n minus r plus 1 into n minus r plus 2 up to n minus 1 into n. If we take r is equal to n, so here the value of r ranges from 0 to n. Clear? Taking r is equal to n, if we take r is equal to n, then the left hand side of the expression will be n factorial upon n minus n factorial, which is equal to n minus 0 plus 1 into n minus 0 plus 2 up to n minus 1 into n. This implies n factorial upon 0 factorial is equal to n minus r plus 1. Oh, it will be n minus n plus 1, n minus n plus 2 set up to n minus 1 into n. N minus n plus 1 into n minus n plus 2. Just a minute, guys. N factorial by 0 factorial is equal to n minus n plus 1 into n minus n plus 2 up to n minus 1 into n. This implies n factorial upon 0 factorial equals to 1, 2, 3 up to n minus 1 into n. You see the right hand side is the continued product from 1 to n, that will be n factorial. So n factorial upon 0 factorial, n factorial upon 0 factorial is equal to n factorial. This implies 0 factorial is equal to n factorial upon n factorial. N factorial upon n factorial is equal to 1. So hence it is proved. So 0 factorial is equal to 1. Clear? So let us come to discuss couple of questions on factorial. Oh, shit. 1, 3, 5 up to 2n minus 1 is equal to 2n factorial upon 2 to the power n into n factorial. Proof कल के पिले ओके, ठीक है अच्छा अभिषेक, आई विल एक्सप्लेन इट। अभिषेक, आर यू जेई एस्पिरेंट? वन इंटू थ्री इंटू फाइव अप टू टू एन माइनस वन। वन इंटू थ्री इंटू फाइव अप टू टू एन माइनस वन. So we have to convert into factorial notation. In the right hand side, the numerator is 2n factorial. You know, 2n factorial is the continued product from 1 to 2n. So from 1 to 2n, all the odd numbers are available. Even numbers are not there. To make it 2n factorial, we have to introduce all the even numbers in between 1 and 2n. So this is equal to, this can be done 1 into 2 into 3 into 4 up to 2n minus 1 into 2n. Now we have multiplied 2, 4, 6 up to 2n. To nullify, we have to divide by the same quantity. Divided by 2 into 4 into 6 up to 2n. Clear? Now you see the numerator is continued product from 1 to 2n. That will be 2n factorial divided by, so each term in the denominator is a multiple of 2. The first one can be written as 1 into 2, second one 2 into 2, 3 into 2 up to n into 2. So if you take a 2 from each term and n terms are there, it will be 2 to the power n into 1 into 2 into 3 up to n. So continued product from 1 to n is n factorial. This is equal to 2n factorial upon 2 to the power n into n factorial. Abhishek, is it clear? Okay. Next question. Find the remainder if 1 factorial plus 2 factorial plus 3 factorial plus up to 100 factorial is divided by 15. And the remainder if 1 factorial plus 2 factorial plus 3 factorial plus up to 100 factorial is divided by 15. What is the answer? Abhishek. Find the remainder if 1 factorial plus 2 factorial plus 3 factorial plus 100 factorial is divided by 15. The solution is 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial, 6 factorial, 7 factorial, up to 100 factorial, right? You see, in 5 factorial, 3 and 5 is there. So 5 factorial is divisible by 15. 6 in 6 factorial, 3 into 5 is there. It is divisible by 6, 15. So each term starting from 5 factorial to 100 factorial is divisible by 15. So if you divide the sum of 5 factorial to 100 factorial by 15, the remainder will be 0. So the total remainder will be remainder dividing 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial by 15. You know, এইটু এ পর্যন্ত সমস্ত 15 রে ডিভিজিবল, তাহলে this sum is divisible by 15. So remainder of on dividing this sum by 15 will be 0. তাহলে এইটাକୁ 15 রে ডিভাইড করলে রিমাইন্ডার কেতে আসছে ଦେଖିବା. 1 factorial is 1, 2 factorial is 2, 3 factorial is 6 and 4 factorial is 24, which is equal to 33. If you divide 33 by 15, then the remainder will be 2, 3. So answer is 3. Did you understand? Hello? Okay. Next question. Prove that 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial equals n plus 1 factorial minus 1. 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial is equal to n plus 1 factorial minus 1.
Proof देखो प्ले 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus up to n into n factorial. This is equal to, so we can write this one so in sigma notation we can write it as sigma r is equal to 1 to n r into r factorial. Okay, thank you Abhishek. This is equal to sigma r is equal to 1 to n r factorial into r. This is equal to sigma r is equal to 1 to n r factorial into r plus 1 minus 1. Quickly note it down. We will go to next page. Okay. This is equal to sigma r is equal to 1 to n r factorial into r plus 1 minus 1. This is equal to sigma r equals to 1 to n r factorial into r plus 1 is r plus 1 factorial minus r factorial into r factorial. This is a telescoping series. If you substitute 1, 2 factorial minus 1 factorial plus if you substitute r is equal to 2, 3 factorial minus 2 factorial plus 4 factorial minus 3 factorial plus up to n factorial minus n minus 1 factorial. Here it will be n minus 1 factorial. So this series cancels. What is left over? N factorial minus 1. Okay. Next question. Evaluate sigma r is equal to 1 to 20 r upon r plus 1 factorial. Evaluate sigma r is equal to 1 to 20 r upon r plus 1 factorial.
Yes, this is also a telescoping series. Abhishek, do you know what is telescoping series? R upon R plus 1 factorial. This is equal to sigma R is equal to 1 to 20 R plus 1 minus 1 upon R plus 1 factorial. This is equal to sigma R is equal to 1 to 20 R plus 1 upon R plus 1 factorial minus 1 upon R plus 1 factorial. This is equal to sigma R is equal to 1 to 20 1 upon R plus 1 by R plus 1 1 upon R factorial minus 1 upon R plus 1 factorial. Okay. So now take R is equal to 1. It will be 1 by 1 factorial minus 1 by 2 factorial. Then if you take R is equal to 2, 1 by 2 factorial minus 1 by 3 factorial plus 1 by 3 factorial minus 1 by 4 factorial plus up to 1 by 19 factorial minus 1 by 20 factorial. This is equal to 1 minus 1 by, this is 1 by 20 factorial minus 21 factorial. 1 minus 1 by 21 factorial. This is equal to 21 factorial minus 1 upon 21 factorial. Just a minute. So guys, factorial part is over. Now I will go for permutation. If you, Abhishek, if you are really JEE aspirant, you can ask me doubts. Okay. You may take my personal number. Are you taking any private tuition? Okay. So self-preparation. You may ask doubts. My number is 9777832 547. You can call for your doubts. Okay. Calling Bril Sushant. And I have request, please visit my YouTube channel named MS Spark and comment on it. Acha. So you have a YouTube channel. So what are you doing in this channel? So are you uploading any content? Content related to IIT. Good, good. Who is your JEE mentor? Then come to permutation. Oh. Your father is a teacher? The synonym for permutation is arrangement. You can teach me properly. Which subject? Each of the different arrangements. So, what is your father? An engineer? Each of the different arrangements, those can be made. Oh, doctor. Each of the different arrangements, those can be made out of a number of objects. Each of the different arrangements, those can be made out of a number of objects taken all or some at a time. Each of the different arrangements, those can be made out of a number of objects taken all or some at a time. It's called a permutation. Each of the different arrangements, those can be made out of a number of objects taken all or some at a time is called a permutation. Right? So suppose we have three objects taking two at a time. We have to write different arrangements. What are the possible arrangements taking two at a time? One of the arrangement will be a B. The second one will be BA, BC, CB, AC, and CA. Right? So there are six arrangements. The arrangement AB is different from the arrangement BA because what is the difference between these two arrangements? In these two arrangements, relative positions of A and B are changed. Clear? Similarly, in BC and CB, order of the objects is changed. AC and C, order of the objects are changed. So there are 6 arrangements possible by taking 2 at a time from 3 given objects. Clear? Since here the number of objects are objects is small, number of objects is 3 only, and taking 2 at a time, manually you can handle this question. But if number of objects is very large, suppose 100 objects are there, and find the number of permutation taking 50 at a time. So there is no possibility that you can handle it manually. You have to use the formula, right? So, so write down a note point. In permutation, order of the objects is taken into consideration. In permutation, order of the objects is taken into consideration. In permutation, order of the objects is taken into consideration. That means if the order of 2 objects changes, then permutation will be a different permutation. Write down a theorem. The number of permutations of n distinct objects the number of permutations of n distinct objects taken are at a time where 0 less equal to r less equal to n is denoted by NPR or PNR. NPR or PNR means number of permutation of n objects taken r at a time. Permutation of n objects taken r at a time, which is defined by NPR is equal to n factorial upon r factorial NPR is equal to n factorial upon n minus r factorial. NPR equals n factorial upon n minus r factorial. The number of permutations of n distinct objects taken r at a time where 0 less or equal to r less or equal to n is denoted by NPR or PNR, which is defined by NPR is equal to n factorial upon n minus r factorial. Come to the proof of this theorem. The number of permutations of n distinct objects taken r at a time is same or equal to the number of ways n boys can be seated in a row having r places. Isn't it? The number of permutations of n distinct objects taken r at a time is equal to the number of ways n boys can be seated in a row having r places. Let these n boys be boy 1, boy 2, boy 3 up to boy n. Let these n boys be boy 1, boy 2, boy 3 up to boy n. So these n boys will be seated in a row having r places. This is first place. Here repetition is not allowed. This is second place. This is third place. And this is earth place. Okay. Since n boys are there, the first place can be occupied by any one of the n boys. So the possible ways of filling up the first position is n. The boy who sits in first positions simultaneously can't sit in the second position. For second position, how many boys are available? For second position, n minus one options are available, and that can be done in n minus one ways. Once these two places are filled up, how many boys are left with n minus two? And this place can be filled up in n minus two ways. Similarly, the last place can be filled up in n minus r plus one. First place is n, that is n minus 1 plus 1. Second place is n minus 1, that is n minus 2 plus 1. Third place is n minus 2, that is n minus 3 plus 1. And likewise, the rth place will be n minus r plus 1. So by fundamental principle of multiplication, the total number of ways all the three places can be, all the r places can be filled up is equal to n minus r plus 1 into n minus r plus 2 up to n minus 2 into n minus 1 into n. Okay. Now our work is to convert this expression into factorial notation. This is a continued product from n minus r plus 1 to n. To convert into factorial notation, we have to multiply this expression with continued product 1, 2, 3 up to n minus r. So this is equal to 1 into 2 into 3 up to n minus r, then n minus r plus 1, then n minus r plus 2 up to n minus 1 upon n divided by, so to nullify we have to divide by the same quantity, that is 1, 2, 3 up to n minus r, 1 into 2 into 3 up to n minus r. Now you see the numerator is continued product from 1 to n, that will be n factorial, and denominator is continued product from 1 to n minus r, which is equal to n minus r factorial. Hence proved NPR is equal to n factorial upon n minus r factorial. Done. I hope it is clear to you. Okay. Wait for a minute. Is it clear, guys? Who is Mr. Curiosity? Okay. So NPR is equal to n factorial upon n minus r factorial. So 5p2 is equal to 5 factorial upon 5 minus 2 factorial, which is equal to 5 factorial upon 3 factorial is equal to 4 into 5. 6p3 is equal to 6 factorial upon 3 factorial, which is equal to 4 into 5 into 6 is equal to 120. Okay. आम ए कौन करें जो क्वेश्चन गुड़ा फंडामेंटल प्रिंसिपल ऑफ मल्टीप्लिकेशन रे करथले डायरेक्टली परमुटेशन अप्लाई करिया. क्वेश्चन नोट लिख. The repetition of digits how many 3-digit numbers can be formed by using the digits 1, 2, 3, 4, 5 if repetition of digits is not allowed. That means with distinct digits. So number of 3-digit numbers using the digits 1, 2, 3, 4, 5 with repetition without repetition is equal to number of permutations of 5 objects taken 3 at a time. So solution will be 5p3. 5p3 is equal to 5 factorial upon 5 minus 3 factorial. This is equal to 5 factorial upon 2 factorial, which is equal to 3 into 4 into 5, which is equal to 60. Yes, you are correct, Abhishek. Okay. Then come to some important points on permutation. The number of permutations the number of permutations of n distinct objects taken r at a time in which a particular object the number of permutations of n distinct objects taken r at a time in which a particular object always appears at a particular place the number of permutations of n distinct objects taken r at a time in which a particular object always appears at a particular place is n minus 1 p r minus 1, which is equal to n minus 1 factorial upon n minus 1 minus r minus 1 factorial, which is equal to n minus 1 factorial upon n minus r factorial. Come to the explanation. N objects are there and they will be arranged in r places. Let these n objects be a1, a2, a3, a4 up to an, and the r places. This is first place, this is second place, this is third place, and this is rth place. Clear? The number of permutations of n distinct objects taken r at a time in which a particular object always appears at a particular place. Suppose a2 always appears and always it takes the third place. Suppose a2 always appears and a2 always takes the third place. So we will put a2 in the third place. When third place is occupied by a2, then how many objects are left over? The number of objects left over is n minus 1. How many places left over? The number of places left over is r minus 1. So n minus 1 objects can be arranged in r minus 1 places in how many ways? N minus 1 p r minus 1. Okay. N minus 1 p r minus 1. Now the question is, where is to apply this note point 1? Okay. The arrangements or the information of numbers, if 0 is there, then this formula, this note point will be applied. So quickly note it down. I will go to the question. Guys, just a minute. I have to make a call to the program coordinator. Okay. Okay, Abhishek, I got your message. So, write down a question. How many four-digit numbers with distinct digits how many four-digit numbers with distinct digits? Distinct digits means repetition of digits is not allowed. Can be formed by using the digits 0, 1, 2, 3, 4, 5. Okay. So come to the solution. We'll use the note point here. How many digits are there? 6 digits. You have to form a 4-digit number. This should be done in 6p4 ways. 6p4 is equal to 6 factorial upon 6 minus 4 factorial. This is equal to 6 factorial upon 2 factorial, which is equal to 3, 4, 5 into 6. This is equal to 360. Okay. In these 360 numbers, there is possibility that 0 may be at the extreme left position. If 0 is at the extreme left position, the number will be 3-digit number. Now we have to count how many numbers are possible taking 0 at the extreme left position. The particular object is taken at a particular place. Taking 0 at the extreme left position, how many positions are left over? 3 positions. How many numbers are left over to be arranged? 5. And that can be done in 5p3 ways. This is equal to 5 factorial. Yes, Abhishek, you are correct. 5 factorial upon 3 factorial. So, sorry, 5 factorial upon 2 factorial. This is equal to 3, 4, 5. 3, 4, 5 is equal to 60. Okay. So, these 60 numbers, in these 60 numbers, 0 is at the extreme left positions. They are included in these 360 numbers. So, total number of such numbers is equal to 360 minus of 60 is equal to 300. Okay. Okay. So number of such numbers is equal to 360 minus 60 is equal to 300. Okay. So guys, here's today's session is over. Rest of the thing we'll discuss in our next session. I think my next schedule is on next month. Okay. 2 more schedules are there in mathematics, and that schedule will be covered by another mathematics teacher. Okay.